When you look at the Australian curriculum, one of the content strands is geometry. And if we want to link geometry with the proficiency strands of problem solving and reasoning, we need to think carefully about the rich tasks that we provide to our children. So here's an example. It's been around for a while, but basically involves joining 4 cubes together. Now, it might be called 4 cube houses, it goes by different names, but I'm just joining 4 cubes here together to create a piece. Now, the question I would like to get children to look at is, how many different 4 cube house designs can you make? We need to clarify a few points when we do this though, because 2 children might make pretty well the same piece here. Right, so we can see that they might build it that way or they might show it that way, and so we need to talk a little bit about the idea of the orientation. So in other words, this 4 cube house and that one are essentially the same. All we've done is turned it round or rotated it, flipped it, and so forth. So the question is, how many different 4 cube houses can you make? That's my first question, so that one's different. How many different 4 cube houses can you make? And the second question is, how will you know when you've found them all? And the reason I like to ask the second question is it encourages children to be systematic, it encourages them to record or have samples there, and it really gets some discussion going about really what is different and what's the same, and how I can sort of systematically record and show what I've developed.